Hello everyone. Today we're going to be talking about derivatives. I'm David Alfaro and my other group mates are Robin Gonzalez and Juan Luis Anton Velasco. Now, what is a derivative? It is one of the most important parts of calculus that describes the rate of change of a function. It is the slope of the tangent line on any point of a curve. First, we will start with the basic rules. First rule we will talk about is the constant rule. C is any constant equals to 0. The derivative of a constant is always 0 because constants do not change. So the rate of change is 0. C could be 7, would equal 0. It could be 5, it would equal 0. And that's how the constant rule works. Rule number 2 is the power rule, where the derivative with respect to x of x to the nth power equals nx to the n minus 1. For our first example, we are given f of x equals x squared. The exponent 2, put it in front, and it'll be 2x to the power of 2 minus 1, which equals 2x. And that would be f prime of x equals 2x, and that'll be your answer. Number 2, we can have f of x equals x to the power of 5. Then we will take 5 to find derivative, 5x, and then 5 minus 1, which equals 5x to the 4th power. That is our derivative for that example. Example number 3, with a negative exponent, given f of x equals x negative 3, it'll be the same thing. We take negative 3x and negative 3 minus 1, which equals negative 3x to the power of negative 4, and that's our answer. On our fourth example, we're going to use square root of x, which also equals x to the power of 1/2. Then we'll take that 1/2 in front of x and have 1/2 x to the power of 1/2 minus 1, or 2 over 2, which equals f prime of x equals 1/2 x negative 1/2. And we can simplify that even more to 1 over 2 square root of x, and that'll be our answer using a square root. And finally, for our last example, we'll use a fraction, 1 over x to the power of 4, which if we take the reciprocal is x negative 4. And then f prime of x equals negative 4, because that is our exponent, x minus 4 minus 1, which equals negative 4x minus 5. And we can simplify that as well to negative 4 over x to the power of 5. And that'll be our final answer using the power rule. Our third topic of discussion is the constant multiple rule, where you have a constant and then the function where c stays in front and you multiply it by the derivative of f of x. For example, we're given f of x equals 5x cubed. We have f prime of x. We keep 5 in front, multiply it by the derivative of x cubed, which is 3x squared. Multiply 5 by 3, you get f prime of x equals 15x squared. That's your answer for example number 1. Number 2, we use a negative number this time, negative 7x to the power of 4. So same thing for f prime of x, you keep that constant in front, negative 7 times the derivative of x to the power of 4, which is 4x cubed. Now multiply negative 7 by 4, which equals negative 28x cubed. And that is your answer for number 2. Another example, we'll be using the square root. So we have 10 square root of x. F prime of x equals 10, because that's our constant. And then multiply it by simplifying or finding the derivative of square root of x, which is 1 over 2 square root of x. And this equals 5 over square root of x. That is our answer. And lastly, let's have f of x equals 1/2 x to the power of negative 1. We'll get f prime of x equals the constant, so 1 over 2, times the derivative of x negative 1, which is negative x to the power of negative 2, equals negative 1 over 2x squared. Next we have the sum and difference rules. This difference would look just like this one, except we would replace the addition symbols with a minus. For an example, f of x equals x squared plus 3x. So we would have to get the derivative of this, which is f of x, and derivative of g of x for f prime of x equals 2x, where we bring 2 right here and subtract 1, plus 3x, which just equals 3, and that is your answer for example number 1. For number 2, we are given x cubed minus x squared. So f prime of x, f of x, the derivative is 3x squared minus 2x. And that is our answer. Our third example, we're given 4x to the power 4 plus 5x squared minus 7. And f prime of x equals, the first one, the derivative of 4x to the power 4 is 16x cubed. So we multiply these two and subtract 4 by 1, plus 10x. And because of our constant rule, negative 7 equals 0. So our final answer is 16x cubed plus 10x for number 3. Example number 4, let's add a square root again. Square root of x plus 1 over x. So first we need to find the derivative of this, which now we know as 1 over 2 square root of x. And because the derivative of 1 over x is negative, it is now minus 1 over x squared, and that is f prime of x. Lastly, we have f of x equals x to the power of 5 minus 3x cubed plus 2x. Same process, find the derivative of each. X to the power of 5 is 5x to the power of 4 minus 3 times 3, 9, 3 minus 1, x squared plus 2. Get rid of x. And f prime of x, that is our answer for example number 5. So basically we just differentiate each term individually and then add or subtract as shown. The second to the last rule that I will be talking about is the product rule, where you get the derivative of f of x, so f prime x times g of x, and then f of x times g prime of x. So to simplify, we could think of it as derivative of the first times the second plus the first times the derivative of the second. For example, if we are given x times sine x, we have identified the two functions x and sine x, and then find the derivative of each, which f prime of x will be 1, which is the derivative of x, and g prime of x, which is cosine x, the derivative of sine of x. And then we just plug it into our formula up here as 1 times sine x plus x times cosine x. And our answer will look like this. F prime of x equals sine x, which is 1 times sine x, plus x times cosine x, which is x cosine x. And that is our answer for example number 1. Example number 2, we are given f of x equals x squared and e to the power of x. These are our two functions, f of x and g of x, and we need to find the derivative of both. So f prime of x is 2x, and the derivative of e to the power of x is e to the power of x. Now we apply that to our rule. X squared times ex equals 2x. So this is how it will look plugged into our formula, and then we factor f prime of x equals e to the power of x times 2x plus x squared. That is our f prime of x. Let us try with polynomial example. We are given x squared plus 1 times x cubed minus 2. We identify both functions. F of x is that, and g of x is x cubed minus 2. And to find the derivative, f prime x is 2x, constants equals 0, and f prime, or g prime x equals 3x squared. Product, if applied to the product rule, we get f prime of x equals 2x. We have f prime of x times g of x, and then f of x and g prime of x. And then we can expand if needed. F prime of x equals 2x to the power of 4 minus 4x plus 3x to the power of 4 plus 3x squared, which equals 5x to the power of 4 plus 3x squared minus 4x. That will be our f prime of x.
Hello, this is Robin Gonzalez, and I'll be starting off with long division. Let's start with the function f of x is equal to 7x. Going back to the formula, let's say that the derivative of f, written as f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. To find its derivative, we substitute our function, so now we get the limit as h approaches 0 of 7 times x plus h minus 7x divided by h. Expanding this, 7x plus 7h minus 7x divided by h, and the 7x terms cancel out, leaving us with 7h over h, which simplifies to 7. Therefore, the derivative of f of x is equal to 7x is simply f prime of x is equal to 7. Next up is f of x is equal to 2x squared. Now we substitute our function, then get the f prime of x is equal to the limit as h approaches 0 of 2 times x plus h squared minus 2x squared, all divided by h. Expanding the squared term, we have 2 times the quantity of x squared plus 2xh plus h squared minus 2x squared, all divided by h. Now multiplying the first term, giving us the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 2x, all divided by h. Then the 2x squared terms get cancelled, leaving 4xh plus 2h squared all over h. Next up, we factor out h, which leaves to h times 4x plus 2h all over h. Next up is h will be cancelled, leaving 4x plus 2h. As h approaches 0, the 2h term vanishes and we're left with 4x. Therefore, our final answer will be f prime of x is equal to 4x. For the next problem, which is f of x is equal to x squared plus 2x plus 1, we follow the same process wherein after substitution and expansion, we get the limit as h approaches 0 of x plus h squared plus 2 times x plus h plus 1 minus 2x minus 1 all over h. Then most terms cancel out, leaving us with 2xh plus h squared plus 2h all divided by h. Factoring out h, giving us h times 2x plus h plus 2 all divided by h, then h will be cancelled, leaving us to 2x plus h plus 2. As h approaches 0, we're left with 2x plus 2. Therefore, the derivative is f prime of x is equal to 2x plus 1. Next up is f of x is equal to 5x squared plus 3x. Following the limit definition and expansion process, we end up with the limit as h approaches 0 of 10xh plus 5h squared plus 3h all divided by h. Factoring out h gives us h times 10x plus 5h plus 3 all divided by h. Canceling out the h, we have 10x plus 5h plus 3. As h approaches to 0, we have the final answer of f prime of x is equal to 10x plus 3. And lastly, for the difficult function, we have f of x is equal to 2x cubed minus 4x squared plus x minus 6. We just follow the same process but with more terms, so after substitution, expansion, and cancellation of like terms, we end up with the limit as h approaches 0 of 6x squared h plus 6xh squared plus 2h cubed minus 8xh minus 4h squared plus h divided by h. Factoring out h gives us h times 6x squared plus 6xh plus 2h squared minus 8x minus 4h plus 1 divided by h. Then h will be cancelled, leaving 6x squared plus 6xh plus 2h squared minus 8x minus 4h plus 1. As h approaches 0, the term with h will be gone and the derivative will be f prime of x is equal to 6x squared minus 8x plus 1.
So hi everyone, I will be discussing the higher derivatives. So what are the higher derivatives? So higher derivatives are obtained I repeatedly. So differentiating a function or its derivatives multiple times. So the first derivative is f to the So now let's solve in each of the derivatives from first until fourth. So we'll do the example. F of x is equal to 5x cubed minus 3x squared plus 10x negative 5. So the first derivative, so f x and f of first derivative, then d over dx is 5x cubed negative d over x again, 3x squared, and then plus d over dx to the 10x, 10x minus d over dx times 5, and then this simplify it, so f of x 15x squared negative 6x plus 10. So that's the first derivative. So now we will be doing the second derivative. So we will write again the example. F of x is equal to 5x cubed 3x squared plus 10x negative 5. So the second derivative is fx, so is equal to d over dx 15x squared 6x plus 10. So now we will simplify it. So f to the second derivative x, so 30x minus 6. So that's how you get the second derivative. And now we will be doing the third derivative. So f the third derivative of x is equal to d over dx 30x minus 6. So f to the third derivative x is equal only to 30. Since 6 has no x, so we will put it out, and 30 x is single, so we got the 30. Lastly, the fourth derivative, so f x equal to 30. So f for x equals to d over x, so 30 is now equals to 0. So now we will elaborate the summary table. So derivative, so the first one x fx, then the expression, so 5x 3 10x. So this is the example, and then the first derivative f of x, so the answer is 15x squared 6x plus 10. Second one, the second derivative is 30x minus 6, and then the third one is 30 until the fourth derivative is 0. Another example is the r. T is equals to 3t squared plus 8t 1/2 plus et. So we'll be doing cos x, which is dy is equals to cos x. So the first derivative is r t is equal to 60 plus 40 minus 1/2 plus et. Second one is 6 minus 2t negative 3.5 plus et. So the third one is 3t 5.5 plus et. Then the last is the derivative of the fourth minus 15 over 2 t minus 7 over 2 plus et. So on this formula we use the f over y is equals to sin 3y plus e 2y minus negative plus in 7y.